Welcome back to section 7.6. In the first video, we looked at a couple of examples where we got one solution. I want to look at some of the special cases where you get no solution or infinitely many and see what those look like. So in example 3, the equations that we have are x minus y plus z equals 4. The second equation is negative 3x plus 3y minus 3z equals negative 12. And the third equation is 2x minus 2y plus 2z equals 8. So probably the first thing I would think is it's in standard form. I think elimination would make a lot of sense for trying to solve. So how about we look at equations 1 and 2. If I take my equation 1 and multiply it by 3, that's going to match up nicely with my equation 2. Equation 1, if I multiply both sides by 3, I will get 3x minus 3y plus 3z equals 12. I'm not doing anything at all to my equation 2 because it matches up now. You have negative 3x plus 3y minus 3z equals negative 12. When I add those two together, everything cancels. 3x plus negative 3x is 0. Negative 3y plus 3y is 0. 3z minus 3z is 0. 12 plus negative 12 is 0. You get 0 equals 0. And what that tells me is that 1 and 2 are the exact same plane. Okay? So the thing is, though, that we do have a third plane. We need to see, is it the same? Is it intersecting to form a line with those two? Or is it parallel to them? Okay? So let's look at 1 and 3, okay? So I'm going to take my equation 1, and just so I can use my elimination, I'm going to multiply it by negative 2 so it matches up with equation 3. For my equation 1, if I multiply both sides by negative 2, I'll get negative 2x, positive 2y, negative 2z, and a negative 8. Equation 3, I'm not doing anything to it. I'm just going to keep it exactly like it is. And when I use my elimination and I add those two equations together, everything cancels out again. Negative 2x plus 2x is 0. 2y plus negative 2y is 0, negative 2z plus 2z is 0, and negative 8 plus 8 is 0. So we get 0 equals 0 again, which means that plane 1 and 3 are also the same plane. And if 1 and 3 are the same, 1 and 2 are the same, that means that all three of these are exactly the same plane. So we are going to have infinitely many solutions, and the solutions are going to be the plane that we have up here. All right, let's try another one. In example 4, I have a mess of fractions, which I'm sure we're going to want to clear out a little bit at the beginning. Let's see. My first equation looks pretty nice. It's 2x plus 3y minus z equals 8. My second equation is 1/2 x plus 3/4 y minus 1/4 z equals 2. My third equation is x plus 3/2 y minus 1/2 z equals negative 6. So probably the first thing I would like to do is just clear out my fractions so they look a little bit cleaner. So I'm going to take equation number 2 and I'm going to multiply it by 4 since that's my least common denominator. When I multiply everything by 4, I'll get a 2x plus 3y minus 1z equals 8. And I notice that is identical to equation 1. So 1 and 2 are definitely the same plane because they simplified to be the same equation. Let's look at equation 3. My least common denominator would be 2. So that would be 2x plus 3y minus 1z, and 2 times negative 6 is negative 12. And what I notice is everything lines up except for that number here. And so you may notice what it probably is. It's going to be parallel. But if you don't, what you also could do is use that elimination step. And I'll take a plane 1. I'm just going to multiply it by -1 so that they're opposite signs. That'll be a -2x, a -3y, positive 1z, and a -8. And if I add those two equations together, the x's, y's, and z's all cancel out, so we have a 0 on the left side. -12 plus -8 is -20. That's a false statement. That's no solution. So essentially what we have here is two planes that are the same and one plane that's parallel to those same planes. Since that third one is parallel and it never intersects, we have no solution for example 4. Now it's your all's turn. You get to try one and show me how much you've learned.